Very good morning, students. Am I audible? Students, am I audible? Okay, thank you. So, students, today we continue our Mathematics 1 lecture, that is Fourier series, with the topic even odd functions. Okay, so in previous lecture, we did the formula of even odd, right? So, the even odd function, and these functions for the limit minus pi to pi. Okay, so as we know, if our given period is minus pi to pi and function is even, so at that time our first step is bn equal to 0. We have to directly write down bn equal to 0, and formula for an, that is 2 by pi 0 to pi f of x dx, and sorry, a0 is 2 by pi 0 to pi f of x dx, and an 2 by pi 0 to pi f of x cos nx dx, right? It means the formula for Fourier series, that is a0 by 2 summation n 1 to infinity an cos nx only. Similarly, for the odd function, if our period is minus pi to pi and our given function is odd function, at that time our first step must be 0 equal to an equal to 0. It means we have to just find bn, and formula for bn is 2 by pi 0 to pi f of x sine nx dx. Okay, and the Fourier series is summation n 1 to infinity bn sine nx. Okay, so this is the formula for the even odd function with the limit minus pi to pi. So today we will continue our lecture with the example of even odd functions. Okay, suppose our question is find Fourier series of f of x is equal to x cube in the interval minus pi to pi. The interval minus pi to pi. At that time, we have to first write down that our here solution is f of x is equal to x cube is an odd functions. Okay, x cube is an odd functions. So the next step is, as given function is odd function and our limits are minus pi to pi. So next step is a0 equal to an equal to 0. Then bn. Bn is 2 by pi 0 to pi f of x sine nx dx, right? So 2 by pi 0 to pi, our function f of x is x cube sine nx dx. So the integration of this x cube sine nx. So here we have to apply the Leibniz rule, that is u dot v rule. So x cube keep it same. The integration of sine nx is minus cos nx upon n minus derivative of this x cube is 3x square. Here the integration of minus cos nx is minus sine nx upon n square plus 6x. Here integration of sine is minus cos, so minus minus plus, that is cos nx upon n cube minus 6, derivative of 6x is 6, and the integration of cos nx is sine nx upon n raised to 4. Okay, and the limits are 0 to pi. Here the derivative of 6 is 0, so no need to write the more, uh, more term, right? 2 by pi. So here the if we apply the upper limit, that is x cube. So we have here pi cube minus cos n pi. The value of cos n pi is minus 1, right? Minus 1 raised to n. So minus 1 raised to n upon n. Minus, if we apply here in the second term pi, then 3 pi square, but sin n pi is 0. So our second term will be 0. Plus 6 pi. And again, the value of cos n pi is minus 1, so minus 1 raised to n upon n cube. Value of cos n pi is minus 1 raised to n. And minus sin n pi is 0, so fourth term is 0. So this is the value of upper limit. Minus value for the lower limit here, x cube. So 0 cube is 0. So our first term is 0 for the lower limit. Second term is also 0 because x square. So 0 square and sin 0 is also 0, right? Plus here cos 0 is 1. But here if we put 6 into 0, so 0 into anything is 0. And in the last term sin 0 is 0. So this is the value for the lower limit. Okay. So after the simplification of this term, see 2 by pi, this is pi cube here minus, this one is minus 1 raised to n upon n minus 6 pi minus 1 raised to n upon n cube, right? So if we get pi common, then both pi will be cancelled. So our answer is minus, if we get minus also common, then pi square minus 1 raised to n upon n minus 6. So it's here, this is, if we get minus 1 minus pi minus 1 raised to n common, then if this is minus, this one is 2, here minus 1 raised to n, pi will be cancelled. So the remaining term is pi square upon n minus here 6 upon n cube. So this is the answer of the Bn. Okay, this is the answer of Bn. So the just a minute. Hemak, how is 6 pi minus? Which 6 pi? Okay, okay. This one, right? This is plus. So this one is plus. Okay, by mistake I have written here minus. Okay, okay. So the series f of x is equal to summation n 1 to infinity bn sin nx, right? And the value of bn is 2 here minus. Okay, students, this term is, see, this one is minus, this one is plus, right? So if I get minus, so last term will be minus. Okay, here I keep this minus common. Then this will be minus. If you don't want to get common term, then it is okay, right? So this is The answer is minus 2 minus 1 raised to n in the bracket. Minus 2 minus 2 minus 1 raised to n in the bracket. Our answer is pi square by n minus 6 upon n cube. Pi square by n minus 6 upon n cube. Okay. So this is the Fourier series for the given example, as our given function is odd here, right? Now, suppose our question is find Fourier series of f of x is equal to mod x in the interval minus pi to pi. Okay, f of x is equal to mod x in the interval minus pi to pi. So, for the solution is here f of x is equal to mod x is even function, and our given function is even. So our first step is bn equal to 0. As our given function is even, limits are minus pi to pi, so bn equal to 0. So a0, the formula for a0 is 2 by pi 0 to pi f of x dx. Okay, so 2 by pi 0 to pi, here mod x is x, mod x dx. So 2 by pi, here 0 to pi x dx. So 2 by pi, integration of x is x square by 2, and limits are 0 to pi. So 2 by pi, if I get 2 common, both 2 will be cancelled, right? And by substituting the upper limit and lower limit, answer will be pi square minus 0, that is just pi square. So 2 cancel, 1 pi cancel. So value of a0 is just pi. Value of a0 is pi, right? Pi square by pi, so it is pi. Now, for an, for an, Srishti, here uh, your query is, ma'am, how can we write mod x as positive and not negative? Okay. See, Srishti, here we consider mod x is even function. And what is the, see, if f of x is equal to mod x, right? So if we take f of x is equal to minus x, then that is, if we take here minus x, then minus x is also, because it is a mod, so minus x is x. This one is also x. Okay, so if we take is x, or if we take minus x, but the minus mode is x only. Got it? Srishti, now your doubt is clear? Srishti? Okay. So, as for an, 2 by pi 0 to pi f of x cos nx dx. So 2 by pi 0 to pi mod x cos nx dx. So 2 by pi 0 to pi x cos nx dx, and 2 by pi. Here we are using Leibniz rule, so x keep it same. Integration of cos nx is sin nx upon n, minus derivative of x is 1. Integration of the sin nx is minus cos nx upon n square, right? And the limits are 0 to pi. So 2 by pi, by substituting upper limit, students, sin n pi is 0. So our first limit is 0. Minus minus plus cos n pi is minus 1 raised to n upon n square. So this is the value of upper limit. Now for the lower limit, is 0 into sin 0, that is 0, plus cos 0 is 1, so 1 upon n square. This is for the lower limit. Now here 2 by pi minus 1 raised to n upon n square, plus minus is minus here, right? So this is minus 1 upon n square. So here 2 upon pi n square. The remaining term is minus 1 raised to n minus 1. So this is the value of an. So for the Fourier series, f of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx. And the value of a0 is pi. The value of a0 is pi, right? And the value of an is 2 upon pi n square minus 1 raised to n minus 1. So pi by 2 summation n 1 to infinity 2 upon pi n square minus 1 raised to n minus 1 cos nx. So students, this is the formula for Fourier series. Okay. If if they ask deduce pi square by 8 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square. So 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, like that. Okay, if they ask, then here, see, minus 1 raised to n. If we take n is odd number, then this will be minus 1. And if we take n is even number, then it is plus. So if we take n even, then 1 minus 1 is 0. So we get this value if, or we get these terms if our n is odd. And for the n odd n, it is minus 2, minus 1 minus 1, it is minus 2, minus 2 into 2, it is minus 4. So if our n is odd, because for even n, it will be 0. Students, please listen carefully. For even n, it will be 0. So for odd n, it is minus 4 by pi summation n 1 to infinity cos nx upon n square. Students, have you any doubt for this term? Have you any doubt? Okay, okay. So continue. Here, uh, n is odd. Okay, so we will write here for odd n, it is 1 upon 1 square, 1 upon 3 square, 1 upon 5 square. Or else we also write this here for odd n, cos x upon 1 square, right? Cos 3x upon 3 square plus cos 5x upon 5 square, like that. Because it is applicable for only odd n. Now here left hand side is mod x, right? So if we put x equal to 0 both the side, if we put x equal to 0 both the side, then this is 0, this is pi by 2 minus 4 by pi. And if we take 0, cos 0, and cos 0 is 1 as you know. So 1 upon, it is not, right? So 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, like that. And after simplification, if we take these two terms here pi by 2, then this is minus pi by 2, right? Minus 4 upon pi. Here 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, up to so on. And if we take minus common from both the side and we take 4 by pi the left hand side, our answer will be pi square by 8, 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, like that. Students, again I repeat, here if we take n equal to even, if we take n equal to even, this term will be 0. Okay, so we'll continue for n equal to odd only. For n equal to odd, this one is minus 1, so minus 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 1 minus 1, that is minus 2. Minus 2 into 2, that is minus 4. So we keep minus 4 out of the summation, that is minus 4 upon 5. And if we apply odd n for n equal to 1, that is cos x upon 1 square, cos 3x upon 3 square, cos 5x upon 5 square, like that. Okay. Now, if we take x equal to 0, both the side, if we take x equal to 0, both the side, the left hand side is 0, here pi by 2 minus 4 by pi, for all cos 0 is 1. So 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, up to so on. And if we keep pi by 2 left hand side, then we have minus pi by 2. And our right hand side is minus 4 by pi and the bracket, right? So if we take minus common from both the side, then this pi into pi is pi square and 4 2s are 8. So our left hand side is pi square by 8 and the right hand side is this bracket. This is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. It is what we want to prove. Okay. Pi square by 8, 1 upon 1 square, 1 upon 3 square, 1 upon 5 square. So, if in exam, if you have asked find Fourier series, then you have to do till here only. Then you have to do till this step only. Okay, but this step only. But if you have to ask deduce this type of series, then you have to do the further step. Have you any queries, students? Have you any queries, students? Otherwise, we will move for the discontinuous functions. Have you any query? Please confirm in the chat box. Okay. So many students are answering that they have no query. So we move for the further examples. That is okay. Okay. Thank you, students. So students, till now we did the example of even odd function for the continuous function. Okay. We have did one example of odd function and one for even function, and both are continuous. Now we will move for the discontinuous function. Suppose our question is find Fourier series of f of x is equal to pi plus x Here minus pi less than x less than 0 and is equal to pi minus x. Here 0 less than x less than pi. Okay. Our question is find Fourier series of f of x is equal to pi plus x when the limit is minus pi to 0 and pi minus x when the limit is 0 to pi. Students, here our overall integral or overall limit is minus pi to pi, right? Our overall limit is minus pi to pi, but our function is discontinuous at 0. So, as our given limit is minus pi to pi, first we have to check our given function is even or odd. Our given function is even or odd. So, let's check. See, listen carefully. How you will check if your given function is even or odd? See, this is in the first function. If you substitute or if you replace minus x by x, if you replace minus x by x, and if you get your lower function, see, what is our first function? That is pi plus x. If you replace here minus x, what you will get? In pi plus x, if you replace x by minus x, what you will get? You will get pi minus x. This is your lower function. Okay. And in the lower functions, if you replace by minus x, then what you will get? Pi plus x. That is your first function. So the given function is even function. When you replace minus x in the first function and you get the lower function, or you get minus x in the lower functions and you will get the first function, then the given function is even functions. This is the trick to check for the even functions. Okay, I'm repeat. See, again I repeat. Have you checked the given function is even or odd? For that, it is very easy. Students, you have to replace minus x in the first function and you get the lower function. When you replace minus x in the first function and you get the lower function. Or you replace minus x in the lower function and you get the function, first function. At that time, your given function is even function. At that time, what if there? Now, students, it is for only one discontinuity. This is not for two discontinuities. Okay, Unnati? Unnati, it is applicable for only one discontinuity. And in your exam, this type of example for one discontinuity only. Okay. So, students, suppose, see, this is, suppose you have asked minus pi plus x and next function is pi minus x. Okay. At that time, if you replace, ma'am, we have to replace x by minus x in any one functions. Yes, Hemant, you have to replace x by minus x in any one functions. If it is applicable in any one function, then it is applicable for both. You no need to check for the both function. Okay. Students, if your question is minus pi plus x and here pi minus x and you replace your first function by minus x, then what you will get? You will get minus pi minus x. So both are different. At that time, your function is not even function. Both are different. So at that time, your function is not even function. So we talk about this one. So Let's start. Here, solution. Here, our given function f of x is an even function. Students, have you any query about how to check even function or odd function for the discontinuous function? Have you any query? Have you any doubt? How to check even function or odd function for the discontinuous function? Okay. So again, at last time I repeat. Okay. Again, last time I repeat. If we replace minus x by minus x in first and we get the other function, or or if we replace minus x by x in lower function and if we get the first function, then our given function is even function. Then our given function is even function, right? And as our given function is even function, our first step is bn equal to 0. Our first step is bn equal to 0. So let's start with the a0, and formula for even function for a0 is 2 by pi 0 to pi f of x dx, right? So 2 by pi 0 to pi. Students, please see carefully here. As our integral is 0 to pi, so 0 to pi, what is our function? Our function is just pi minus x for 0 to pi. So we have to substitute here pi minus x only. Okay. Now, for a0, 2 by pi. Integration of this pi minus x is pi x. Integration of this pi is pi x. Integration of x is x square by 2. And the limits are 0 to pi. So 2 by pi. After substituting upper limit, here we have pi square minus pi square by 2. And for lower limit, both the value 0. So pi square minus pi square by 2, that is pi square by 2, right? 2 by pi here, pi square by 2. And after simplification, our answer is pi. After simplification, answer is pi. So you have to keep remember when you are applying even function formula for the discontinuous function. At that time, you have to do your question, your f of x for the limit 0 to pi only. Now, same for the an. The formula of an is 2 by pi 0 to pi f of x cos nx dx, right? So 2 by pi 0 to pi. What is for the 0 to pi? What is your function? For 0 to pi, your function is for 0 to pi, your function is pi minus x. So here pi minus x, because your integral is 0 to pi cos nx dx. So 2 by pi, you have to apply here Leibniz rule. Pi minus x, keep it same. Integration of cos nx is sin nx upon n minus the derivative of pi minus x is minus 1. Integration of sin nx is minus cos nx upon n square, right? And the limits are 0 to pi. So 2 by pi. After applying upper limit, here pi minus pi is 0, sin n pi is also 0, so first term is 0. Minus 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 3 times. Cos n pi is minus 1 raised to n upon n square. Okay, this is for the upper limit. And for the lower limit, if we apply here, pi minus 0 is pi, but sin 0 is 0. So first term is 0 minus cos 0 is 1, so 1 upon n square. So 2 by pi, this is minus minus 1 raised to n upon n square plus 1 upon n square. So after simplifying, 2 upon pi n square. If I keep this one is positive, so 1 first minus 1 raised to n. Okay, so this is the value of an. So our Fourier series is f of x is equal to a0 by 2 summation n 1 to infinity an cos nx. So what is the value of a0? Our a0 is pi. A0 is pi, right? And an is 2 upon pi n square, 1 minus 1 raised to n. So this is pi by 2. Here summation n 1 to infinity, 2 upon pi n square, 1 minus 1 raised to n cos nx. So this is the Fourier series for the given discontinuous function in the integral minus pi to pi. Students, have you any query? Have you any query for the given for this Fourier series? Okay, so this is the most important topic, students, as per the GTU exam. Every time one question from even or topic, it may be continuous function or it may be discontinuous function. So please keep in mind. Okay, today we have another lecture, lecture number 3. So we'll continue our discontinuous function of and then we will do the other topic, that is the limit for 0 to 2 pi. We should not use the limit of minus pi to 0 in this kind of sum. Yes, we should not use the limit minus pi to 0. We have to apply just 0 to pi. Ma'am, why we not take pi plus x? Divya, see, see Divya, here in the formula, this is our formula for a. Okay, see, this is the main formula. See Divya, this is the formula. When our given function is even, then we apply this type of formula, and when our given function is odd, then we apply this type of formula, as when our integral is minus pi to pi specially, right? So, as in the formula, our limits are 0 to pi, so we have to apply functions which is lies between 0 to pi only. So we have to apply function which is lies between 0 to pi only, right? Got it, Divya? Okay. Divya, got it now? Okay. Okay, students. So our lecture will conclude very shortly. So we'll